Okay, so this is where we left off. We said that the final velocity when the book bag hits the ground is 26.9 meters per second. One thing that the calculations over here did not give you is the direction. Remember that velocity is a vector quantity and it has a direction. We said that anything that goes up is a positive direction and anything that goes down is the negative direction. In this case, the book bag is going downwards, so we need to assign a negative over here. Okay, this is very important and a lot of students miss it. The calculations won't give you the negative, but you still need to assign it because this negative means that the book bag is going downwards. Okay, so now we're officially ready to solve part B of the problem. Part B says, how many seconds does the book bag take to hit the ground? So how many seconds from here to here? Alright, the kinematic equation that I'm going to use to solve this is V final is equal to V initial plus the acceleration in the y direction times the time, because time is what we're looking for and we have every other variable, so I can use this equation to solve for time. Okay, so the final velocity is negative 26.9. I'm not going to write the units until the end. Okay, the initial velocity, let me see, the initial velocity is 6 meters per second. Okay, let me erase the units because I said I wasn't going to write that. So 6 meters per second is the initial velocity. The acceleration due to gravity is negative 9.8 meters per second squared, and finally time, which is what we're looking for. So to solve this, I'm going to move the 6 over to the other side. Alright, let's see what this gives me on the calculator. Negative 26.9 minus 6, so it gives me negative 32.9. That's what I'm going to write here. Negative 32.9 is equal to negative 9.8 t. Now to solve for t, you simply divide both sides by negative 9.8. Negative 9.8. And now you're going to get your time. Okay, so we have negative 32.9 divided by negative 9.8, and that gives you 3.35 or 3.36, around there, 3.36 seconds. Okay, so it takes about 3.36 seconds for the book bag to hit the ground. It takes 3.36 seconds for the book bag to hit the ground. So that's part B. Part C is the hardest one actually of them all, and you're gonna see why in just a second. It says, what is the greatest height that the book bag reaches? Okay, so you're probably thinking, wait a minute, if the book bag is dropped from a height of 35, then isn't 35 the greatest height? And the answer is no, because what happens is that the balloon is going upwards at a velocity of 6 meters per second. So what that means is that when you drop the book bag at a height of 35 meters per second, the book bag, because it has an initial velocity, it's actually going to do this. It's going to go a little bit higher, and then it's going to drop down to the ground. Okay? So that's what it's going to do. It's going to rise a little bit more, just a little bit, above those 35 meters. And one thing that I want you guys to understand is that when the book bag gets up here, okay, then the book bag is going to have a 0 meter per second velocity. So when the book bag gets up here, it is officially going to stop moving, and then it's going to begin moving again in the downward direction. So what is the greatest height that the book bag reaches? Okay, so we have to use another kinematic equation, and I'm going to use this equation one more time. So V final squared is equal to V initial squared plus 2A times the final distance in the y direction minus the initial distance in the y direction. Okay, so first I want to look at this one right here, the initial velocity. What is the initial velocity of the book bag? So the initial velocity of the book bag is the same as the balloon, which is 6 meters per second. So that is what I'm going to put there. So 6 meters per second is the initial velocity. Now that we did this, let's look at the final velocity. A lot of you are probably thinking that the final velocity is this one right here, and this is actually not true. This is the final velocity when the book bag hits the ground, but what we're looking for is the final velocity up here at the highest point. Okay, so the final velocity when the book bag hits the ground is not the same thing as the final velocity up here, which is what we're interested in. We know that the initial velocity is 6 meters per second, and the final velocity is the one that's up here. So this is 0 meters per second because the ball is still at that point. So that's a tricky one. And that's why I decided to do this problem, because I know that this problem is a little bit complicated. Okay, so the acceleration we know is negative 9.8. Okay. The initial height is 35 meters, and the final height is what we're looking for. So we said that the book bag was dropped from a height of 35 meters, but now we need to find out what that little tiny height up here is. Okay, so the book bag was dropped from 35 meters above the ground, but we want to know what's the highest that the book bag is going to go up when it's dropped from the balloon. So this just becomes a simple calculator problem. 6 squared is 36. Okay, I'm going to plug this in the calculator. Let me clear this. So we have 2 times negative 9.8 is equal to negative 19.6. So I'm going to write that there. I'm going to erase this. Okay, so it's negative 19.6 y minus 35. Okay, I'm going to distribute the negative 19.6 onto the y and onto the negative 35. So negative 19.6 times y is negative 19.6y, and negative 19.6 times negative 35 is, okay, negative 19.6 times negative, times negative 35 is 686. So this is 686. Okay, let's combine the like terms, this right here and this. We can combine that. So we have 36 plus 686. That gives us 722. 722. Okay, and now to solve this, I'm going to move the 722 over to the other side of the equation. We have negative 722 is equal to negative 19.6y. And to solve for y, I'm going to divide by negative 19.6. Negative 19.6. This cancels. Y is equal to, okay, so we have negative 722 divided by negative 19.6. So the answer is 36.83 meters. Okay, so this is the highest that the book bag is going to go, and it kind of makes sense because if the book bag was dropped from 35 meters, okay, it's only going to go up a little tiny bit, so that tiny bit is 36, which is what we just found out. Okay, we just found out that the highest the book bag is going to go up is 36.83 meters. Okay, so this concludes this video. I hope the example helped.